So now we're going to get a little more serious about these higher order functions. We're going to get into map. This one is a little bit different conceptually. The sort and the for each, these are things we've dealt with before, but map, this one's going into uncharted waters, as they say. So we want to consider map whenever you have a collection of something, so an array of something, and you want to convert it to a collection of something else, an array of something else, but of the same size. So you have 10 strings and you would like to have an array of ints of the lengths of all those 10 strings. So it's still going to have 10 values in it, but it could be anything else. You might take an array of 10 names and map it to an array of 10 places of popularity for that name. Or you might have 42 instances of addresses, and you want to convert those to 42 instances of locations with coordinates, latitude and longitude. You can think of it as convert, but don't just pigeonhole it as something that converts one thing to another. It's a mapping, but you don't necessarily have to convert. You might do something completely different with it. But basically, you have a collection of X things, and you want to create a collection of the same size of something else. You want to map one to the other. So let's look at some examples. Take an array of strings and produce an array of the members' lengths. So that would then be an array of strings to an array of ints. Take an array of company instances and create an array of company names, just the strings out of those instances. Or use an array of file names to generate an array of data instances of the file's contents. So you have a parameter type that's being passed in, and the type is the type of the array. So your closure in a map is going to take the same type of whatever the instances are in your collection. But the return type is whatever you want. So if you're going to return an array of the lengths of the strings, then your return type would be int, and the return type of map would be an array of ints. So let's look at this in our playground. So back in Xcode, I'm going to delete everything after my variable of array of names, and I'm going to use map. And let's say we're going to map it to the lengths of these. So I'm going to say on line 3, let lens equals names dot map. Look at the signature of the parameter being passed in. It takes a string and returns t, because we don't know yet, or at least the compiler doesn't know yet. So it just says t. It's a generic. Okay, so I'm going to hit return, and once again I have the placeholder highlighted, so I'll hit return again, and it's going to tell me, well, what do you name the parameter? Well, it's going to be called once for every item in the array of my names, so I'll say val1, and I'm looking for the lengths, and so I'm going to say int. Well, now the return type of map is going to be an array of ints. So map returns an array of whatever type I defined in place of t. In our case, it's an int. So map is going to return an array of ints. I will return the val1.count, so that's the length. And if I print lens, then it should print the lengths of each of my strings. 4, 4, 5, 6. And that's exactly right. So I mapped my collection of names to a collection of lengths. It's as simple as that. It's not very complicated, but sometimes conceptually it can be complicated. But again, if you're ever thinking to yourself, I've got this array of this, and I sure wish I could have an array, and for each one of those, get that. Well, that's what map does. So that's what you should use in that case. And just remember that whatever you're returning from your closure, map is returning an array of those same types. So the next higher order function we're going to look at is filter. So filter does what it says. It filters out items from a collection. So once again, just like the other ones we've looked at, it takes a closure with one parameter, just like we saw before with map. And the parameter type is the type of the items in our array. And it returns a bool. If your closure returns true, it keeps it. If it turns false, it filters it out. So the result of filter is going to be an array of the same type as your collection, so strings, ints, whatever the original one, as the same size or smaller. If you don't filter out any, it's just going to be another array of the same things. So let's take a look at that in our playground. Okay, so we have this array of names, and we want to filter out any names with a length less than 5. So we know we're going to filter out these first two. I'll put another one at the end that's short. I'll just say it's ASD, so that we know that we can filter out some from the beginning and any other position in the array. So I'll say let longer names equal names.filter. Notice what it takes. It takes a closure that takes a string and returns a bool. Notice the name of this parameter is included. It's like a question. Is it included? If you return true, it is included. If you return false, it's not included. But it's going to be, the return type is going to be the same as what you're calling on the collection. So in this case, it's going to be an array of strings. Again, I will press return. I'll name the parameter val1, and I need to return true to keep the item. So I'll return val1.count greater than 4. So anything greater than 4, Jenna and Andrew, those will be kept. So I can print longer names, and it should be just those two, and it sure is. So again, filter takes a closure of this type, whatever type the array has in it, in our case string, and returns a bool, true to keep it, false to pitch it, and the result is going to be a collection of the same type, in our case strings, with any items that fail our condition, any items that return false for this. So that's filter. Just by the name, you know what it's doing. It's filtering some things out. Now we're going to get just a teeny bit more complicated. Not really much more. Let's say you have your array of names and you want to map them to the lengths, but only for the ones that are longer than 4. So you could do a filter and filter out those items, and then you could do a map to ints. So let's look at that. So back over in our playground, I got the longer names, and then I can say let lens equal longer names dot map, and I'm going to pass in val1. My return type is an int, and I'm going to return the val1 dot count. And now what I have, if I print out the lens, is I'm going to have an array of the lengths, but only of the longer names. So I filtered, and then I mapped. There's got to be an easier way. I know that's what you're saying to yourself, and you're right. So CompactMap combines map and filter. So it's very much the same as a map, but it returns an optional. So instead of returning bool for yes to keep it and false to filter it out, you're going to return an optional. You're going to return the value to keep it and nil to filter it out. So let's look at that. So we have it done this way. Let's try it another way. I'm going to say on line 13, let lens2 equal names.compactMap. And again, notice the signature. String, element of result, question mark. So this is the same. It's a generic. You could think of it as T question mark. So it's an optional. So again, val1, and we're dealing with what again? Length, so int, but it's an optional. So all I have to do is return val1 count greater than, what was it? 4. That's right. If it's greater than 4, then return val1.count. Otherwise, return nil. That means filter it out. So return the value to keep it and the nil to filter it out. So now if we print lens2 and we run this, it should be the same exact thing. And it sure is. Look at that. CompactMap. In one line, we did 2 different operations. We did a filter, we did a map. It's much more readable, it's much more focused, it's more precise, and it communicates to everybody else what you were intending to do. You are getting your black belt, my friend. This is where you really get strong and swift. Now we're going to talk just a minute about FlatMap. So FlatMap is what CompactMap used to be called in previous versions of Swift. Now it's called CompactMap for all the collections, but FlatMap is still around. You can call FlatMap on optionals. You can think of it as a single element mapping, or a single element compact mapping actually, because you can return nil. So you have an optional and you want to get something out of it, but you may return a nil, you can use FlatMap. To be honest, I don't use it that often, but I definitely want to cover it. I want you to be aware of what it does. So let's say we have, let's take a simple example. On line 19, I'll type let some val, and I'll declare it as a string optional, equal a string that says some string. And then I want to map that to something. So I'll say let some map equals some val dot FlatMap. It's the same signature. It takes a string because that's what this is. It's a string optional. So it's going to return a string in there. So it's going to unwrap it. It's only going to call if it actually has a value. So I'll call that val1, and we will return int optional. And I'm going to say, kind of like I did before the CompactMap, I'm going to say return val1.count greater than 5. If it's true, I'll return val1.count. Otherwise, I'll return nil. So now some map would have to have the type int optional because it might return a nil. So on line 24, if I print some map, it should equal optional 11 because it returned an optional. Now, if I say only if it's greater than 50, which some string is not, then it's going to return nil. So this is a way that you could take an optional, convert it potentially into something else using FlatMap. So this is a higher order function, but it's not on a collection. That's perfectly fine. Our initial examples of a higher order function weren't either. But CompactMap used to be called FlatMap, so there could be some confusion there, but just be aware that they are two different things, although FlatMap is still around, but only for optionals. The next higher order function we want to talk about is reduce. Now, for some reason, a lot of people tend to have a problem getting the concept of reduce. I know I did. Just like map, you want to call it convert. It converts. It converts. It's not necessarily it. It's a little bit broader than that. You can do a lot more with it. Reduce is the same way. It takes a collection and produces one value. And that's it. Don't overthink it again. It's taking a bunch of things and coming out with one. That might mean it sums them together, might mean it concatenates them, it might mean it merges them together some other way or takes them apart somehow. But the idea is you take a bunch of things and you come up with one value. So you could call it boiling down, you could call it combining, you could call it reducing. And that's what it's called, reduce. So it takes a collection, produces one value. It has an initial starting value. That's called the initial result. And then each time your closure is called, that ongoing result is passed in, and you can then create the next ongoing result, and so forth and so on. It'd be like if I said, okay, starting with 0, I want you to add 5, now 10, now 20. What's the result? Or starting with 100, I want you to subtract 20, now 5, now 5 again, and you tell me the result. It's this ongoing. You have to remember what the last value was. So let's look at it in practice. So I'm going to go back to the top and I'm going to delete all of my code except for my array of names. And now we're going to reduce. So I'll say let reduce val equal names dot reduce. And again, notice there's two parameters. There's the initial result and then there's the closure. So let's say we want to concatenate all the names, an easy one. So the initial result will be an empty string. That's what we're starting with. And the next parameter is the closure. It takes a result. This is the ongoing value. And then a string. And it's a string, of course, because our names contains strings. So we'll call the first parameter ongoing and the second parameter val1. Now the result has to be the same type as your initial value and your ongoing value. Since this is a string, ongoing is a string, your result needs to be a string. So we're going to return the next value. Well, that's going to be ongoing plus val1. Now I'm not putting a space in between these two, which I probably should do, or maybe one on the end. So now I'm concatenating all these values. Print reduce val on line 6, and now I've put them all together. Since our starting value was blank, there's nothing at the beginning. If I wanted it to start as something, I could say names, something like that, and then when I run it, it's prepended with names. Let's say I want to reduce it to the total length of all the names. I could say let total len equal names.reduce, And now my initial result is 0. That's where I'm starting. So these two results need to be the same type. Notice the type, result for my initial value, result for my ongoing, and result for what it returns. So if I start with 0, this needs to be an int. So we'll call it ongoing, and it's now an int. And the name is still a string. I'll call that val1 again. And then this result needs to be an int. So I'll return ongoing plus val1 count. And when I print this out, I should have a total number of all the characters and all the names, 22. Now, if I started this at 100 for some reason, it would be 122. To demonstrate that, I will print out the ongoing. Every time this gets called, I'll print out the ongoing. So the first time it's 100, then I add 4 for Bear, 104, 4 for Kyle, 5 for Jenna, 6 for Andrew, and 3 more for ASD. So we took all of these values and reduced them to something. The first time it was a long string. The second time it was the number of characters. So I hope that clears up what reduce does for you. It takes a bunch of values and reduces it down to one, something that's meaningful to you in your app. Now we're going to talk about a few other higher order functions that may not need as much attention. First, we're going to talk about first. So first returns the first item to match your criteria. So let's say we want to look for the first item that is longer than 4 characters. I'm sorry if that's a boring example. I know it, but I'm trying to focus on the concept and not get too muddled down in the actual functionality of it. I'll let you apply it to more complicated examples. So let's say we'll call our result let first long name equal names.first, and you have this where clause, more or less. It takes a string and returns a bool. The first thing that passes is going to return true, and that's where it stops. So it takes a name, I'll call it val1, it returns a bool, and I'll just return val1 count greater than 4. So the first one that's greater than 4 will be assigned to first long, and I'll print that out. So now when I run it, it should print out an optional Jenna because it may not actually find one that long. I can also put in here that it print out the val1 each time. Now we can see how many comparisons it does. Once it gets to Jenna, it stops. Another interesting higher order function is drop. So it will drop the values until it gets to something that doesn't match the criteria. Let's say we're going to drop all the names that contain the letter A. So we'll say non-A names equals names.drop while what? While this is true. So we'll say val1, and we're going to say return val1 contains A. I'm not checking the case, so I could put in here for val1 lowercase, and now anything that has an A is going to get dropped until it gets to a name that doesn't have an A. So I'll say print non-A names. Now watch what happens. It has Kyle in there. It has Jenna, Andrew, and A. These have A. That's because it dropped until it got to the one that was false. So it dropped this one. Now, for example, let's say you wanted to drop all these shorter names. So you say return val.count less than 5. So what do you get? Well, ASD is in there. Well, that's not right. It's less than 5. So you might want to first sort your names by length. So you could chain those together. You could first sort it and then call drop. But you understand that it's dropping until it doesn't meet the criteria. Let's look at another one called split. So we're going to split it into multiple array slices based on some criteria. So we'll say let splits equal names split, and then the where separator. We'll say where is val1, the parameter's name is val1, and we're going to say where it contains return name contains, again we'll say A. And again I want to lowercase it. Oops, look what I did. I used names, val1 lowercased. And then we will print splits. And let's see what it prints out. Okay, so it only printed out Kyle because Kyle is the only one that doesn't contain an A. Everything else contains an A, and so it was split up. It's easier to see if we put something like a Y in there. Now, the first one is Bear, Jenna, Andrew, and ASD is the second one. So it split it based on Kyle. When I split it based on A, it removed Bear because that was where it was splitting, Jenna, Andrew, and ASD. It split them all, and we were just left with Kyle. But when we split on Kyle, the only one with a Y, we get these, and then we get these. If we split based on E, all 4 of these would be gone. If we split based on K, again, it would be Kyle. If we split based on J, let's try that one. Now, when we split it, we'll have everything before Jenna and everything after Jenna. So it split it up based on that. And you can have multiple ones. So let's put a Y in here, go back to Y, and then we'll have 3 results. We'll have Bear, then we split on Kyle, then we have Jenna, then we split on Andrew, and we have ASD. So now we have 3 splits, basically like the separators. And that's how it works. So we looked at first, drop, and split. Some of the lesser used higher order functions, but very, very useful and important to know about.